Thank you for joining. This is a networking lab demonstration. In this video, I will demonstrate basic firewall configuration of the Cisco ASA firewall networking device. A firewall serves as a security barrier between an internal network and external networks. External networks are considered untrusted networks. The Internet is just one example of an external network. The primary purpose of a firewall is to monitor and control incoming and outgoing network traffic based on predetermined security rules. These rules effectively block unauthorized access or intrusions while allowing legitimate communication. Take a look at the topology for this demonstration. Currently, the firewall device is restricting communication across all networks. The internal network cannot communicate with neither the external network nor its own demilitarized zone, DMZ. Likewise, neither the external network nor the DMZ can communicate with the internal network. Right now, an internal device cannot ping any device outside of its network. If I wanted to test to see if an external network is down, I could not do it simply because of the firewall. I also could not access the web server located within the DMZ. Again, that's due to the firewall. I'll have to change the configuration so that certain types of communications, namely ICMP and TCP communications, will be able to pass through the firewall bidirectionally. I'll carry out the configuration in 4 phases. First, the interfaces of the firewall will be given IP addresses, names, and security levels. Second, I'll configure the firewall to handle both DHCP and DNS. I won't focus on DNS in this video. I'll just indicate the firewall as the DNS provider. I do, however, need the internal end devices to be assigned IP addresses dynamically. Instead of a DHCP server, the firewall will handle this for me. The third and fourth phases will create and apply ACLs that will allow the free flow of TCP and ICMP traffic across networks. I want to make note of the correction made to the label of Phase 3 that you see on the topology. It should read ACL outside instead of ACL inside. The ACL in Phase 3 refers to the flow of traffic between inside and outside, while the ACL in Phase 4 refers to the flow of traffic between inside and DMZ. Sorry about that. I want to start by showing you something. At first installation, the firewall blocks all communication. Take a look at PC1's attempt to ping PC5. The ping fails. Now I'll try to ping another network. I'll ping PC8. Again, the ping fails. I'll go back to the web server and attempt to access its default web page, but you get the picture. It will fail. As you can see, the page could not be accessed. Okay, I'll get started configuring the firewall. Just as a note, the firewall has no password configured at first installation. I would be responsible for configuring it, but I'll leave it as is for this video. I just need to hit Enter to go into Enable mode. I'll be doing the following. First, I'll go into Config T mode. Then I'll go into each interface and issue a no-shut command to bring the interface up and proceed assigning an IP address that is consistent with that network link. Subnetting is not a part of this video, but I did use a mask of /27. Next, I'll give the interface a name as well as a security level. The security level will play a part in traffic filtering. A network with a high security level can send communications to a network with a lower security level. However, a network with a lower security level cannot send communications to a network with a higher security. The communication will be blocked by the firewall. The flow of water is used as an analogy. Water flows downstream, but not upstream. Higher levels can flow down, but lower levels cannot flow upward. I also want to note two more things about the security level. A default security level message pops up, but I still explicitly configure the level even if it matches the default. Also, the flow of water rule only allows for higher levels to send messages past the firewall unblocked to lower security levels. However, the communication would still be blocked on return if a reply is required. Pings and TCP messages require a reply by the recipient of the message. A lower level's reply would be blocked by the firewall. I'll finish up on configuring the interfaces. Take a look at the bottom of the topology. The interfaces will be named Inside, Outside, and DMZ. Inside has a security level of 100, meaning that traffic from that network is trusted. Outside has a security level of 0, which means that traffic from that network is untrusted. DMZ, or the demilitarized zone, has a security level of 50. It is more trusted than the outside network, but less trusted than the internal network. This network is separated from the main internal network so that it can be exposed to outside networks without compromising internal network. Because of this exposure, it is only partially trusted. I'll choose the number 50 to indicate this. All right, I just finished configuring for the demilitarized zone. Now for the last interface, this will be the outside interface. I've finished step 1. I'm on to step 2, configuring for DHCP and DNS. As I stated before, I won't focus on DNS, but DHCP will be needed for assignment of IP addresses to the inside end devices. The outside and DMZ will have static interfaces. I'll create a pool of IP addresses and indicate to which interface the pool belongs. I'll then indicate the firewall's own IP address as the DHCP and DNS server address. Finally, I'll enable DHCP for the inside interface. Okay, the pool is created and attached to the inside interface. Now for the DHCP and DNS server address. I'm enabling the DHCP on the interface. Now for steps 3 and 4. I will create and apply access control lists to allow for internal network-issued pings and global web server access. To do this, ICMP and TCP communications must be permitted bidirectionally by the firewall. Remember that I said that the traffic can flow from high level to low level, but any reply would be blocked by a firewall. I want to fix that so that ping tests from the internal network and the web server can be accessed by any network. I will do this by using 2 different access control lists. I will call them the outside ACL and the DMZ ACL. Again, the label on the annotated topology should read ACL outside instead of ACL inside. Now for steps 3 and 4. I will create and apply access control lists to allow for internal network-issued pings and global web server access. To do this, ICMP and TCP communications must be permitted bidirectionally by the firewall. Remember that I said that the traffic can flow from high level to low level, but any reply would be blocked by a firewall. I want to fix that so that ping tests from the internal network and the web server can be accessed by any network. I will do this by using 2 different access control lists. I will call them the inside-outside ACL and the inside DMZ ACL. Again, the label on the annotated topology should read ACL outside instead of ACL inside. Okay, that was the outside ACL. Now for the DMZ ACL. That was ICMP. I'll do TCP and then apply the access list using the access group command. Applying the DMZ ACL to the DMZ interface. Okay, that's it for configuration. Now I'll go back and check for IP assignments to the end devices of the internal network now that DHCP has been configured. Then I'll run through the same communication tests using ping and attempting to access the web server. The tests should be successful now that ACLs are being used to permit such communications. Halfway done, so far so good. Okay, great. All end devices of the internal network have been assigned valid IP addresses for the network. Now I'll go back and finish up on my topology labeling so that you can see what device is pinging what device. I'll also label the web server. Give me a moment. Now it's time to ping. I'll have PC1 ping PC8 to see if the ICMP reply gets through the firewall. Actually, I just noticed that the video footage shows me pinging the network itself and not the end device. I'll go back to it later and have PC1 properly ping PC8's IP address. For now, I'll continue on with my commentary. Okay, I'm pinging the web server. The ping is successful. I'll pull up the web server's default web page. The page is properly served back to the browser. Now I'll make sure that outside networks can also access the web server, which is located in the demilitarized zone. I'll use PC8 to test access. Yes, the outside network can also access the web server. I'll go ahead and pull up the page. Hang on. For some reason, it takes a while for the browser to launch. Bear with me. Okay, here we go. I'm typing up the full address. Perfect. The page is properly served back. In this last section of the demonstration, I'll focus on the waterflow rule. Using PCs 1, 5, and 8, I'll more clearly point out how the security levels and ACLs work together to achieve the desired security goal. Okay, zeroing in on the waterflow analogy. Let's recap. The waterflow rule says that water flows from top to bottom only. A security level of 100, which is the inside network, allows the flow to both the DMZ and outside network, which are levels 50 and 0 respectively. The reverse flow, however, is blocked by my firewall because both the DMZ and outside networks have security levels equal to or lower than the inside network. The problem is that certain types of communications issued by my internal network requires a return reply into my secured internal network. The ACLs have fixed that, allowing for pings, which is an ICMP message, and web server requests, which is a TCP message. By specifying the interfaces and traffic direction, in or out, the ACLs retain the security of my inside network. By that I mean that devices coming from neither the outside nor the DMZ can ping my internal network devices. Outside devices can only ping my DMZ. Watch while I demonstrate. Testing water flow high to low. PC1 is located in the inside network and has a security level of 100. It will first ping PC8, which is the outside network and has a security level of 0. The ping is successful, as it should be. Now pinging PC5, which is located in the demilitarized zone and has a security level of 50. This is still high to low. Great, the ping is successful. Now I'll turn to testing low to high traffic flow when communication is initiated by a device with a lower security level. Remember, this is where the firewall kicks in to block low to high by default. I use the DMZ ACLs to overcome the firewall when low to high is needed. In this scenario, only the web server should be accessible. The inside network should not be accessible. Such traffic is blocked by the firewall. PC8, the outside network with a level of 0, is pinging PC1, the inside network with a level of 100. It is properly blocked by the firewall. Even though it is low to high, the outside PC should be able to ping the DMZ's web server, which also has a higher security level of 50. Our ACL allows for such communication to pass through the firewall. Let's see. Yes, the ping into the DMZ is successful. Now I'll just check the ability of a device located within the DMZ to pass through the firewall and ping PC1 located in the inside network. Again, I'm testing low to high, but this communication has no special permissions. It should fail. Excellent. The DMZ's PC5 cannot ping into the internal network. The ping has failed. Well, that's it. Configuration and testing are complete. I have a firewall in place with a configuration that matches the organization's security goals. I hope that you enjoyed the demonstration. For similar demonstrations, I invite you to browse the playlist. Goodbye for now.